Hey guys, so we're going to be doing a little bit more graphing today, but it's going to change up a little bit. We're going to look at graphing from intercepts, and then we're also going to graph some special functions. So let's go ahead and take a look at that.
All right, so just like I said, we're going to be graphing linear equations, just like we have been, but now we're going to be doing it using the x and y intercepts. Now, you've already experienced y-intercept in our slope-intercept form video from the last time. Now we're going to be talking about x-intercept as well. Now, if you remember, we talked about y-intercept being where the graph crosses the y-axis. So, for example, in these two graphs, we've got y-intercepts for this one at -2, so I'm going to go ahead and label that. All right, and I've got another y-intercept from this graph at -4, so I'm going to label that as well. The key thing that I told y'all about that is the y-intercept is always where x is equal to 0. Okay, so you got x equals 0 here. Anything here is going to be the y-intercept in this case on these two lines here at -2 and -4. So y-intercept is where x equals 0. Now, the vice versa is true as well. The x-intercept is where y equals 0. Okay, so y equals 0 on the x-axis, right? Anywhere along this line, y is equal to 0. So for this line right here, it's going to be at -4, so I'm going to label that point. That is one of the x-intercepts. Okay, the x-intercept for this graph will be at 2. Okay, so I'm going to label that as well. Main thing here is you're not always going to be given a graph. So you got to be able to figure out what the y-intercept and the x-intercept is based on the equation. So let's take a look at how we figure that out.
All right, so like I just talked about, in order to find a y-intercept, you got to set x equal to 0, and then vice versa for x-intercepts, you have to set y equal to 0. So we have our example here, all right? In order to graph with the intercepts, we need to figure out what they are. So let's start with y-intercept by plugging 0 in for x here. So we've got -6 times 0, all right? And then you just write the rest out plus 3y equals -18. All right, messed up the 18 a little bit. There is a negative there, I promise. Okay, so -6 times 0 is going to give us 0, so that just goes away, and you end up with 3y equals -18. All right, now in order to graph this intercept, you got to have y by itself, so we're going to divide by 3 on both sides. Okay, 3's cancel over here. You end up with y equals -6. So now we know -6 is our y-intercept. Let's go back and figure out what our x-intercept is. All right, so we found our y-intercept over here. Now let's go over here and find our x-intercept by plugging in 0 for y. So -6x gets to hang out. Then we've got plus 3 times 0 equals -18. All right. So -6x, can't do anything with that. I'm just going to bring that down. 3 times 0 gives us 0, so that goes away. And you just end up with equaling -18. Okay. Need to get rid of this -6. It's multiplying, so we're going to do the opposite and divide by -6 on both sides. The -6's cancel over here, and you end up with just x equaling -18 divided by -6, which is a +3. So we now have our y-intercept and our x-intercept. Let's go ahead and graph.
Now that we figured out our y-intercept and x-intercept, let's use those to graph this equation, -6x plus 3y equals -18. So y-intercept is where our graph crosses the y-axis, and it says it's at -6. So I'm going to go down to -6 on the y-axis, and we plot a point, so we know that that's where we're going to go through with our graph. And then our x-intercept is where we cross the x-axis, and it says that it is at 3. So we're going to go over to 3 on the x-axis, plot that point, and then you guys know what to do from here. You pick these 2 points, and there's our line. Alright, so now we're going to take a look at a couple of those special functions that are mentioned in the title. So, one of the types of special functions you're going to see is where it's just y equals a number. Now, you may have to do a little rearranging to get it to look like this, but you will end up with some equations that are just y equals some number. Like this one here is y equals 4. So, where you're going to start any of these is plot any points that you know where y equals 4. So I'm going to go up to 4 on the y-axis. I'm going to go ahead and plot a point there. And then I'm just going to go anywhere else that y is 4. So let's go over here to x equals 5. Okay, I'm going to go up, and there's 4. Okay, I've got 2 points, so I could just draw a line now, but let's just keep going. -6. All right, -6. I'm going to go up to 4. Boom, there's another point. I think you can start to see kind of the pattern that's going on here. No matter where I go, this line is going to end up being horizontal. Okay, so that goes through all those points. All right, so the main thing to remember when we're talking about equations that look like y equals a number is that it's always going to be a horizontal line. Another special function you'll run into is when it says x equals some number. And again, you may have to do some rearranging to get to this point, but essentially, x equals some number. We're going to look at x equals -2, for example. Okay. Now, we're going to do the same strategy we used on the last one, but now we're talking about where x is equal to -2. So I'm going to look on the x-axis. I've got -2 being right here. So I'm going to plot a point right there. Okay. Let's look at some other places x might equal -2. If I go directly above that, I know that's going to be -2. This point is -2 and then up to 3 on the y-axis. I think here, I think all of these points are going to end up being where x is equal to -2. And now I think you might be noticing these particular points, when you put a line through them, are going to create a vertical line. Okay? So the main thing to remember here is that if the equation is x equals a number, it's a vertical line.
Congratulations!